Ms. Sadila, and also all participants. Hope you still enjoy the summer course. In next 1 hour, I would like to share about machine learning and drug target interaction prediction, and then also show you a video of IJA analytics. Actually, some of part and concept that I was presented in previous session in the before break. Some of part, for example, like interconnection between plant, compound, protein targets and disease, and also prediction, the connection and calculation of synergistic effect already implemented in IJA analytics. We have three versions actually about IJA analytics. The second version actually we did still not include synergetic effect calculation, but in the short IJA analytics, we already have already included the synergetic effect calculations in IJA version 3. Perhaps maybe committee, please type the address of IJA version 2 or version 3 in chat room. Okay, now I would like to continue our session here with the brief explanation about the machine learning and how to use the machine learning concept to drug target interaction predictions. Actually, this example of this case is related to the COVID pandemics, yeah, because when maybe I just explain a brief explanation that before, maybe in February or January 2020, when pandemic is not so widespread in Indonesia, and some researchers in Faculty of Medicine, University of Indonesia, try to implement the machine learning approach for predicting the herbal medicine. The objective is to find the to screen or to conduct the screening compound from the herbal compound with the hope that this herbal medicine can be a potential candidate for preventing the infection of COVID-19. Okay, I will share the screen. So please don't be hesitant if, for example, you have a question when I still deliver the presentation. Please just interrupt me by open your microphone, for example. Can you see my slide?
Yes.
Miss Salida? Okay.
Yes.
Okay. Yes. So this is the outline of this presentation. First, I would like just give a brief description about machine learning, what is machine learning actually is, and I just want to give you maybe the simple example of. Please, the committee, please.
I'm sorry, sir, you muting your microphone.
Hello?
Yes.
Mikrofonnya masih, Pak. Masih di mute.
Okay.
Okay. This is my okay. Let's us continue that the online actually is consists of what is machine learning and then decision tree, the one of example of machine learning, and also the random forest extending of the decision tree concepts. Maybe the third and the fourth method of machine learning, feed forward neural network and support vector machine. I will not explain in this session because the time is limited. So I just bypass the feed forward neural network and support vector machine. I just go to the virtual screening on drug target interactions. Sorry, still there is Indonesian language. So what actually machine learning is, if I think all the people or participants here already know about artificial intelligence or AI, artificial intelligence. So machine learning actually is branch of artificial intelligence concerning with the design and development of algorithm that allow computer to evolve behaviors based on empirical data. So, for example, if we have many data, for example, the drug target interaction data or some amino sequence data like or genomics data, based on the experimental data, then we can use this data to train, to make a computer learn about this data so that they can find the interesting pattern. They can use this data to make generalizations. This concept actually is easy to understand because it's common in our life, our daily life. For example, when we were a child, or for example, if you have a child or maybe a little brother, for example, 2 years old, 2 years old, yes, then you would like to introduce or to teach him or her, to teach him to know about red color or blue color. Yes. So the easy way is just you collect for example, something that have a red color and collect the something that have a blue color. When my child was still 2 years old, I put the red ball and blue ball, only 2 ball. But then I melempar apa bahasa Inggris? I saw for example, the red ball to my son. Okay, I saw the red ball to my son, and I mentioned this is red ball, and then I saw him the blue ball and mention this is the blue ball. I do this action I repeat the action many times. Yes, I repeat the action many times so that my son then can identify which one is red ball, which one is blue ball. And when, for example, I am trying to examine or to test my son. Then I took him to somewhere, and then I try to point something, for example, red house, and I ask him what color of this house, for example, like that, and he can answer red. So based on the training that I've done to my son, then my son can identify which one is red, which one is blue. This is the simple principle of machine learning work. So if, for example, we have the drug target interaction data, so we just transform the data into the characteristic that computer program can learn it, so that the computer program that can identify the pattern, then they can make a decision related according to the data that they learned. This is actually a definition of machine learning. So because we call it that the program is intelligence, so they require knowledge, not just data. The data should be transformed to the knowledge. The data should be transformed to the feature, to the characteristic, the value that program, the computer program can understand. And then computer program can identify the pattern, the interesting pattern, and make a generalization. So the interesting pattern is knowledge that make the computer program can decide, can make a decision for example, if we give the new data to the computer program to identify the new object or the new data. So the basic principle of machine learning, actually, the machine learning is a field in computer science that allows computer to learn without being explicitly programmed. So the principle, if we have a data with label, with class or label, for example, a red color, red ball. So we have a data, for example, ball with label or class red. Okay. In the case of drug target interaction, we have the data with target, with have a label or class. For example, there is interaction or positive interaction. For example, we define the positive interaction for describe that compound or drug have interaction with protein target. Okay. Or except the positive target, we also have the negative interaction. Except the positive interaction, we also have the negative interactions. For example, this negative interaction represent the drug that have no interaction with protein target, or we still unknown if whether the compound or drug have interaction with protein target or not. So in the case of I will write something. So for example, if we have drug target interaction, this is compound. For example, we have a 4 compound, and we have a protein. Then we have interaction here. So in our data, we, for example, the data 1, then we have a S1 and P1. This is the label because there is interaction. So we have we define the value 1 for have interaction. For example, the label is 1 for interaction, there's interaction, and 0, no interaction. Here, we also have a data to compound 1 and protein 2. We see that as compound 1 and protein 2, there is no interaction between them. So the label is 0. And for example, data 3, we have compound 3 and compound protein 3, the label is 1. So we have this data as training data. So when we build the program, then the program will get input of this data and then try to find the pattern from this information or data. So after the program, the machine learning algorithm learn this data, the label data, this is the label data, yeah. Then we have the model. So this model then be used to test the new data. In our case, the label data is come from compound or drug that we collected from conventional, modern, or registered drug or chemical drug or synthetic drug. Like in this case of COVID pandemics, for example, favipiravir, remdesivir, oseltamivir, and so on. And the protein is, for example, for antivirus protein, for example, main protease, spike, and so on. And if there is, for example, interaction between favipiravir with main protease of SARS-CoV-2, then we set the label with the value of 1, like that. Okay, and then the model that built by our machine learning algorithm will be used to predict the compound contained in herbal. For example, in Pisidium guajava, we have hesperidin. The drug, the compound, the name of compound is hesperidin, for example. There is no information label that hesperidin have efficacy or have interaction with main protease or spike from the virus corona, spike of coronavirus. So then this data, hesperidin, will be predicted by our model, so that we can know that, for example, hesperidin have interactions or have positive interaction with the main protease of SARS-CoV-2, for example, like that. I hope you can understand with our explanation. This is basic principle of machine learning. Is like we try to teach our child to identify color, for example, and then we try to test the child, our child, for example, go to somewhere to test whether he can identify the color or not. More conceptual, we distinguish the data into two groups. The first is the data is used for training, for teach the computer program. So usually this activities is started by conducting data acquisitions. We collect data from, for example, from database, a public domain database for in the case of the drug target interaction, yeah, also maybe from literature and so on. And then after we have data, actually the data that we collected is consists of data, two label here, positive and negative. Positive, for example, in the case of drug target interaction is have interaction, and negative label represent the unknown or the data that don't have interaction with between compound and protein. So after we collected the data, then we separate this data into two groups. The first is usually, for example, we have the comparison between 80% for training and 20% for testing. So this data is used for computer program to learn or to find the pattern or the interesting pattern in this data. And the 20% data will be used to test the model that we built. Okay. If any questions, you can just ask the question. This is summer course, not webinar. So like in class, so you are free to interrupt me to ask a question. The core of prediction model is actually algorithm is one of the important thing that determine the quality of our model. So the accuracy of our model or the performance of our model actually is determined by algorithm. So the success of machine learning system also depend not only by data set that we collect, but it's very important because if you collect the bad data, so you learn something that bad. For example, if there is a population, then you conduct the sampling and your sampling data is not represented the population. So the learning algorithm will not effectively work. Okay. If, for example, in the specific domain problem, you have a population and then you try to sampling the population to get a data sampling, to get a sample data for training your model. If your sampling is not accurate, is not represented, do not represent accurately the population. So this will affect the accuracy of your model. So data is very important, but if you have the good data, but you choose the wrong algorithm, not wrong, but maybe not suitable, not proper algorithm, because algorithm, there are many algorithms in machine learning, and each of them have strength and weaknesses. So if, for example, you have a good data set for training, but you are not, but your algorithm is not so proper, so it's not so proper, or it's not so good for this case. So the accuracy of your model also not good. Okay, but in this slide, I just want to emphasize that the algorithm the algorithm actually controls the search to find and build the knowledge structure. So the role of algorithm is how to learn or how to find the pattern, the interesting pattern that can be used to construct knowledge structures, so that the model can make a generalization. Okay, make a generalization of according the problem. So the learning algorithm should extract useful information from training a sample. So this is the key of the good algorithm in classification or prediction model using machine learning. There are actually there are many types of learning, but I just want to show you three of them that very important. First is about supervised learning. Usually this is related to case prediction. Supervised learning actually related to the problem of prediction and classification. And the unsupervised learning, for example, clustering. In the supervised learning, the data have a label, but in unsupervised learning, the data have no label. For example, in protein-protein interaction that we discussed previously, the data actually do not have a label. We only have proteins and their interactions, but we don't know what actually this data belong to for example, belong to one group or the other groups, or maybe the other class or something. In protein-protein interaction, we should find the effective, for example, cluster that can collect in the one group the protein that have a similar characteristic of similar function. But in the supervised learning, we have data with the label, so that if I talk about label in the equation, a mathematical equation, actually like y equal to x plus so label is y in the case of regression, yeah, okay, for example, like that. But in classification, because y output is categorical, yeah? So we call it as label of class. Nah, in supervised learning, yes, we have a data with label, and then we use this data to train or to make a computer program or algorithm, machine learning algorithm, learn this data to construct the model that represent the generalization of the problem. And the third type of learning is semi-supervised learning. We can more clearly distinguish between supervised, unsupervised, and semi-supervised using this illustration. For example, in supervised, the data set already have label. In this case, the label is, for example, red. In this case, is blue, and this is green. Yeah. So, for example, if we have new data with red color, that we can assign it to the red class or red label. And for example, if we have a star with green color, then we can assign to star label or green label. sometimes maybe because the model is not perfect, then the decision is wrong. For example, here there is a red color assigned to the star or green class. So why the model of machine learning have error rate or the accuracy is not perfect, but usually under 100%, for example, 9% or 80% or sometimes 70%. We call it is very good or already good related to the domain problem. However, on the other hand, in unsupervised learning, we don't know about the label. So, for example, this blue color, all of objects, because we don't know the label, we treat them as the same characteristic, blue color. And the objective of unsupervised learning is to make exploration of the characteristic of each object, so that we can make group that then the make group which is inside group contains of object that have a similar characteristic. Maybe the analogy, the simple analogy is, for example, we have a new welcome for new students, because we don't know, for example, and we ask them to come to the big room, and then we just want to know. For example, we invite the student that belong to the, for example, Department of Biology, Department of Mathematics, and Department of Computer Science, but we don't know. We don't have the information which one is belong to that department. So we can make exploration to group them by, for example, make 3 questions. The first question is related to biology. The second question is related to algorithm. The 3 question related to the third relation related to, for example, statistics or mathematics. Then we ask them to do the quiz, and then we evaluate. Most of them that can answer the biology is biology, belong to biology departments, and most of the students that can answer the algorithm problem belong to computer science, and so on. So this is the analogy, the simple analogy how unsupervised learning work. And the semi-unsupervised is, for example, if we have object, we don't have not all objects have a label. So some objects do not have the label. So this is a hybrid approach between supervised and unsupervised learning. And there is many methods in supervised learning. Yes, for example, super vector machine, ML, and so on. I just want to show you the simple one. We call it as decision tree because it's very intuitive. Decision tree. For example, if we have a training data like this, we have a data with attribute 1, attribute 2, 3, and class. This is label. So from this data set, we train, or we will build the model here. So, and that this model will be used to apply to test or to answer the question here. Jadi this is of test set and this is training set. So the first step is learning the algorithm For example, we use the say for the name of algorithm in decision tree is, for example, C 4.5, for example, like that. We use say C 4.5 to learn this data set, so that we will get the tree, the model that consists of decision tree. Then this model will be used to answer the test set. Firstly, in the decision tree, we should decide which attribute that will be the first splitting attributes. For example, we have attribute refund, marital status, taxable income, and this label auto class is cheat. Then the question is, which will be a splitting attribute first? Is it refund or marital status or tax income? So this is how the algorithm will decide the decision tree. Okay. For this, I just want to show you one thing, one simple thing. For example, if we assume that refund is the first splitting attribute, that then we go to actually this computer work. Computer will work with like that, but for the illustration, I will show you the simple simple thing. For example, if we use refund as a splitting attribute, then we can explore this. If refund is yes, no, so the class is no. We can see that if the value of refund is yes, the cheat or the class label always no. So we can do the decision that if refund, the value of refund is yes, then the label is no. But if the value of refund is no, sometimes the label is no, but sometimes the label is yes. So we cannot make a decision without considering the other attributes, because the value of class, if the value of refund is no, sometimes the value of class is no and sometimes is yes. So we cannot make a decision. We should consider the other attribute. For example, we use marital status, and then we can see again if marital status is married, then this is no. Also, if marital status is married, the decision is no. But if this marital status is single or divorce, that we cannot make a decision. We should consider the other attribute. This is actually the logic of the decision tree here. Okay, so it's possible we have the two decision tree. For example, we can maybe the algorithm can produce this model or this model. So there is one. It's possible to have one or more decision tree. Okay, and then after we got a model, then we try to use this model for answer the problem in the test set. For example, we use this model, the first model. Then there is a new data in test set, no merit 80K. So what a decision, yes or no? So we just first try to evaluate. Refund no, so we cannot make a decision because the refund is no. Then marital, then we go to the other attribute, marital status. Marital status is married. Okay, Oh, okay, because marital status is married, then we can make a decision no. So this is test data. So we already had a model, and then the model can be used to predict the value of label. This is that is the explanation, the brief explanation of decision tree. Yeah. There is strength and also limitation. You can read this by yourself in OCW, and also there is a extended of decision tree. We call it as random forest. The difference with the decision tree is in random forest we can generate many trees. So this is like, for example, decision will be better if the decision is conducted by many people than one people. In this case, the decision is better if conducted by many trees compared to one tree. Decision tree is one tree, but if you use random forest, you generate, for example, 100 trees, and then you just conduct the voting from 100 trees, which one, how many trees that make a decision, for example, as a positive interaction, and how many negative interaction. For example, if most of three make a decision as a positive interaction, then the decision result is positive. This is illustration of random forest. And actually, then we now talk about the drug target interaction. Actually, the drug target interaction, the problem is many compounds do not have link protein, and so require link prediction mechanism. We should calculate the similarity of compound and the similarity of protein. I already explained before in the previous session. So the solution is build prediction model using machine learning, for example, decision tree, random forest, neural network, or using multi-label classification. This is a more complex approach, and also link prediction using PLM and EE. In the each cases, we use PLM and EE, PLM and II for the algorithm. I also want to show you about our research that we conducted on the beginning of pandemic in collaboration with Faculty of Medicine, University of Indonesia. This is still in review, but already reviewed in second round. Just waiting for the editor decision. The title is Virtual Screening on Indonesia Herbal Compound as COVID-19 Supportive Therapy, Machine Learning and Pharmacophore Modeling Approach. This is actually, we use the machine learning approach and pharmacophore modeling approach. This is pharmacophore modeling approach is conducted by University of Indonesia, but this is our work in here. The first step is we collect the data. Then we conduct the feature extraction and then build prediction model and validation and testing herbal compounds. Yeah. We collect data from literature or paper and super target database in May, before May, February 2022. So if we talk now, maybe we will get the different data because it's already 1 year ago. Yeah. Data consists of drug, compound, protein target, and their interaction. And we can have a 685 interaction or positive class and 89,000 non-interaction or negative. So our data actually is in balance. Then we try to feature extraction using fingerprint PubChem. I think you already Pak Sony already explained about the fingerprint extractions. And also dipeptide, this is for compound, yeah, but and use the dipeptide composition for protein. For example, if we have an amino acid like this, then we just conducting windowing in computer science. We call it as windowing. Just choose the two, select the two some amino, and then like a window, like sliding window. We slide the window from the beginning to the end of the amino acid sequence. Then, for example, in this case, we identify there is one pair of AA appear here, so we give 1, and DD, there is no DD here, so the value is 0. FF is there is 1, MN is 1, and VD, for example, VD, there is 2 VD here, so we give value, and then we combine the value of from the fingerprint and from the dipeptide composition as the data, so that we get a 1000 to 1081 feature consists of 881 from fingerprint and 400 from dipeptide composition. And this is a sample, our sample. Okay, and then because this class data set is not in balance, so we conducting balancing data set, then divide the data set into 2 groups, 70% for training and 30% for validations. We use 3 types of machine learning approach: random forest, multi-layer perceptron, and support vector machines. And then after getting a model, then we try to validate using this data, and we have accuracy, precision, recall, and measure. And then with the Huygens or the resulted model, then we try to test the herbal compound to the model. So we from the result from the testing, then we have some compound belong to the flavonid compounds, for example, asperidine, camphorol, myricetin, and so on, that have a potential to have a interaction with main protease protein from SARS-CoV-2 virus. And for validating this finding, we try to make a molecular docking with the lopinavir as a control, and we get a result that asperidine, camphorol have a negative result close to the lopinavir. So we conclude that maybe this compound have potential to inhibit the protein of coronavirus. And after that, we conduct the literature study to check which plant actually that contain this compound. So we find there is in Psidium guajava, Citrus aurantium, and Moringa olivifera. Now we still in collaboration with Soho, using the diapet to conduct the in vivo experiment for knowing the efficacy of Pseudomonas Gua Java. Okay, this is the end of my presentation. Before I open the question answer, I asked Nabila, please show the video of Ija. Actually, most of the concept or algorithm that I explained in this course already, some of them already implemented in Ija analytics. Please, Nabila.
Ija bisa menerima masukan dari sisi draft berupa tanaman atau senyawa, target berupa protein dan penyakit, ataupun dari kedua sisi. Tanaman dan penyakit, tanaman dan protein, senyawa dan protein, ataupun senyawa dan penyakit. Input yang sudah dimasukkan juga bisa langsung dihapus dengan button X yang ada di samping kotak input. Atau jika ingin mengulang semua input, bisa langsung mengklik tombol reset. Kemudian berikut adalah contoh case untuk this is input. Mulai pencarian jaringan dengan button search. Ini merupakan halaman outputnya. Pada bagian summary ini ada deskripsi singkat keterhubungan yang didapat dari 5 penyakit yang menjadi input. Di sini didapatkan 3 tanaman, 27 senyawa, dan 21 protein. Selanjutnya, ini adalah grafik keterhubungan dari tanaman, senyawa, protein, penyakit. Dengan mengklik penghubung berwarna abu-abu ini, bisa dilihat deskripsi dari data yang terhubung. Graf ini juga bisa langsung di-download. Kemudian pada metadata teks, di sini adalah list dari tanaman, senyawa, protein, dan penyakit yang terhubung. Untuk memudahkan pengguna, setiap data ini dihubungkan ke beberapa sumber pendukung. Contohnya untuk protein dihubungkan ke Uniprot, untuk senyawa ke DuckBank, untuk tanaman dan penyakit ke Wikipedia. Metadata teks ini juga bisa di-download. Kemudian di sini ada connectivity text yang menggambarkan keterhubungan tanaman, senyawa, protein, dan penyakit dalam bentuk teks. Jika sudah selesai, juga bisa langsung kembali dengan button reset ini. Selanjutnya, di bagian cluster ini, Ija menerima input berdasarkan senyawa farmakologisnya. Di sini ada senyawa analgesik, antibakteri, antiinflamatori, efikasi, aktivitasnya, dan senyawa target. Ini adalah halaman outputnya. Secara general, hampir sama dengan output Ija yang sebelumnya. Hanya saja di sini senyawa terhubung dengan senyawa herbal sebelum terhubung ke tanaman.
In this case, we divide the IJA version 2 and IJA version 3. This synergy component is actually in IJA version 3.
Kemudian, pada bagian sinergis ini dapat dicari skor sinergisitas dari 2 senyawa pada satu penyakit. Nilai yang dihitung berupa agen skor, topologi skor, dan sinergi skor. Di sini juga bisa di-sort. Selanjutnya, pada bagian menu IJA V1, kita bisa mengakses IJA versi terdahulu. Pada bagian download, terdapat buku panduan yang bisa di-download. Pada bagian upload, bisa dimasukkan hasil publikasi mengenai konektivitas atau metadata tanaman, senyawa, protein, dan penyakit. Pada halaman bantuan, dapat bantuan singkat berupa frequently asked question, kemudian ada kontak, dan kemudian yang terakhir adalah kontributor IJA.
Okay, This is actually our material. Is there any question? Is there a moderator here, Miss Sadila, or just?
No, just me actually.
Okay. So I maybe I will answer the question in chat room. Yeah.
Yes,
There
there are
is.
some questions.
Yes, there is some question. For example, from Mr. Slamet Rianto, IPB University. How to using the data as training set while data acquisition is unstructured data from database publication and all the source and that unlabeled. Okay, Mr. Slamarianto. Actually, there is the step in the data mining or machine learning principle or concept is we call it as pre-processing data. So if we, for example, have the unstructured data, we can make the unstructured data become the format that may be suitable for our machine learning algorithm by conducting the pre-processing data. For example, if we our data is image, so we should conduct, for example, segmentation, and the segmentation will transform the unstructured data into that data that will be understood by our computer program. In the case of the, for example, data interaction, drug target interaction, actually the protein-protein interaction network is also unstructured data. So we transform the information of interaction between compound and protein in form of the network become the value of topology metrics such as between the centrality, the degree centrality, and so on. You will learn about it in the practical or hands-on session after this delivery material, after the theory, this session, I think, using the cytoscape. Is it clear, Mr. Slamet Rianto?
Yes, thank you, Doctor.
Okay, the second is how to implement decision tree to extract and recognition protein and compound name from unstructured data such as scientific. Okay, this is actually I have research, yes, as with my students. Yes, this is the interesting question because if we only depend on the public database such as SuperTarget or UniProt or DrugBank, so we still find that most of them did not have interaction, did not have information about interaction between compound and protein, because most of them still in the form of text, only published in the paper or something. So in the case, the problem can be categorized as the text mining. So this is the topics of research, one of the interest topic of research, which our students already developed the method also by using the machine learning, but combining with the text mining in the scope of information retrieval here, like regular expression and so on. So why, for example, we identify the term, but not omit the context, for example, like this. This is become the specific research. We call it as text mining. Okay.
Okay, thank you, Dr. Ananta.
Okay.
Can I have one question, last question?
Okay.
Direct. Okay. How about to my knowledge, a protein or compound's name have several synonym. How about to recognize the name that have several synonym to detect one's protein and then to network in your research. Thank you.
Okay. Yes, this is interesting question. Yes, actually, in the text mining research, we should have a corpus, Mr. Slamet Rianto. So the corpus, like a database, contains of many terminology of, for example, protein or compounds that actually already known. So we store this information in the corpus, so that if, for example, if we find the terminology in from the text, then we can compare to the database, the corpus database that we have, like this. Is it clear?
Okay, thank you for excellent answer.
Oh yes. Okay, Mr. Slamet. Can you show your, open your video, Mr. Slamet? The committees will, so please, the committee screenshot Mr. Slamet. Okay, is there any question? Thank you, Mr. Slamet, or from Dr. Kianto Atmajaya.
Thank you, welcome.
Now what's Chawi? What's Chawi? Now the possibility one plant to combine another plant to make jamu diabetes or for its drug, for example, Christiania with that plant. Can you explain the question, Dr. Kianto? Dr. Kianto? I cannot understand clearly. Chawi, what's Chawi?
Maybe can we know?
Oh, can we? Oh, sorry. Can we know? Sorry. Can we know the possibility one plant to combine another plant to make jamu diabetes or for best drug? Okay. Actually, in IJA or maybe in the computer in research in computer science, as long as I know, we still only can calculate the synergetics of two compounds, the interaction between two compounds using NIMS algorithm. Maybe it's very interesting topics if, for example, we try to extend not only two compounds, but three or more than three compounds. Actually, me and Pak Sony and our student already try to develop the synergetics algorithm to calculate three compounds, interaction between three compounds to show to explore or to see the synergetic effect. But I think this algorithm is still premature, so need validation with many experimental results. I think this is my question. Okay, I think because the time is up, then I give the time to Mr. Sadila. After this is on material and will be coordinated by Dr. Toto Herianto.